stage and keep your questions at the end, and we'll have a great session this evening. Thanks. So, I must admit, one of my failures is planning, leaving it absolutely to the last minute to figure out what to say in a talk. And in fact, I was going around taking polls last night for people I met at the bar about what I should say. And I've been asked to reminisce and ramble on and give anecdotes. And I think that's the sort of thing that's expected of a fellow. But I also had a bunch a majority of people saying, hey, could you talk about the semantic web thing? And I think, so I'm sorry, as a fellow is supposed to mainly reminisce, what I will do is I will talk mainly about the semantic web. However, I will allow myself to digress whenever I feel like it. How about that for you? Okay? And to just talk about whatever comes into my head and to put it in context with a bit of history. Now, this stuff has in fact, this material is on the web, and in fact I presented it before in the UK, and I don't suppose any of you were there exactly a month ago. I talked about this at the Royal Society. Has anybody seen the webcast of that talk? Apart from Bebo, you can ask them for your money back when you leave. Okay. So we'll settle up afterwards. But basically, when it comes to the semantic web, I found that I need to do it with diagrams. I'm sort of diagram-oriented person. So what I'm going to do, first of all, which is kind of funny anyway to do it, is to go back to before the web. Because actually, for a lot of people, some of you sort of not bearded or grey-haired or sort of you don't have the distinguishing marks of people who remember well back before the web, and to just remember what it was like then. Then I'll talk about some of the things which I feel are important about. One is the web's got to remain a universal space. It's got to remain a simple space that can be the foundation for many things. I'll talk about semantic web and talk a bit about the spirit of web development. Mind you, when you go, the spirit in which things have been developed, if you go around the museum, and you find some of the people here, perhaps one of the people around last night, and you get them talking about the way they developed any of this computing stuff. You get you get a lot of the excitement and the spirit of collaboration and stuff, which was a lot of what made being involved in the web at all really fun, apart from the technology. 10 years ago it was really difficult to explain what the web would be like. And now it is so difficult to explain why it was difficult. Because people just, it's like the web. I don't like the web, so yeah. That's what they say nowadays. They're trying to learn a new language. And so it was really it really can be called a paradigm shift. It was a paradigm shift because it actually introduced new concepts and the words for these new concepts in the old days. But you can remember that in a large organization there would be many, many documentation systems. You can remember that when you try to, for example, get some information from one system and put it into another, you go to one system, you maybe tell that to a library system, and then when you tell that into that system, you'd be communicating with a program which you'd have to learn. And the program will be specific to that particular library sometimes, or to that. Certainly you have to learn how to find your way around it. Eventually, you find the information. Having found it, you then copy it down onto the back of an envelope, and often go to another system, another terminal, on a different sort of computer, on a different network, and then connect to some completely different thing. Or you sit down on a PC or a Mac, which were probably connected to different networks, and you find the place where you wanted to actually put this information in, and then you get it on the back of an envelope and you retype it. And that is like the web. And when people say, why did you invent the web? It was, one of the answers is, well, somebody had to, because look what a mess it was. And it's just that
we've got this unbelievable ability to live with a mess. But when in fact all that information was sitting on disks, it was all actually, and all those disks were on machines which were actually connected to the networks. They were on the same Ethernet, they were just talking DECnet or CERNnet or IP or AppleTalk. So it was only software problems. There's only lack of software that made it possible. So that made it impossible. I noticed in this environment that people had attempted to unify this before. And the messages which came out of that were very important. Watching somebody give a seminar to present the new documentation system. So, ladies and gentlemen, I propose that from next month, everything we use should be put in a central documentation system. And all you have to do is to mark it, convert it all to SGML, and store it on the IBM mainframe, and we'll give you all passwords, and put it into this system in which we will divide all our work into document types and document categories, and if you want, you can have subcategories which you can name yourself. Now, spot the problem. Why did this person never get the system adopted? One, he was telling people to use SGML when maybe they didn't want to. Number two, he was telling them to use a particular piece of hardware, which involved using a particular piece of a particular operating system, which was even worse. That was even more of an insult. CERN is a high-energy physics lab where, unlike at SLAC, where I understand that you're only supposed to use one operating system, and I'm not sure which one it is, but at CERN, people came from all over, and there wasn't a central control to say you should only use this machine. So people really had... they arrived from different universities with different machines, and that was life. And you didn't tell them which operating system to use. And even if you tried to tell them what operating system to use, you did not tell them how to organize their life. So if you tell them to organize all their data into columns, and they wanted to organize it into a tree, well, you've had it. So any of these systems, so there are a number of systems came one after the other. These silly people. It didn't succeed because they told everybody to put it on the mainframe. Documentation system version 2 just requires you all to put convert everything to Mac, Word, and put it on floppies, and we'll catalog the floppies, and we'll make a great big virtual floppy disk, and all the Macs will be networked, or whatever it is. Any of these systems tended to impose constraints. So whatever it was that was going to work, that was going to link these systems together, had to be minimally constraining. Clearly, the idea is not to try to foist your ideas about how somebody should think. Just do the minimum to get them to expose how they think to the rest of the community, so that we can actually figure out how their software works when they've gone. So, and doing this is a very non-centralized sort of idea, and it's that non-centralized bit which is difficult to explain now, and it's actually, for the semantic web, it's difficult to explain still. Even though everybody's got the web, taking the same sort of webization idea of taking something centralized and decentralizing it is still tricky. So the solution to the web was start first of all to notice that when looking at all these systems, they all took you through a series of screens. And at each point, you either typed something in or you clicked on something, or you did the equivalent of clicking on something with a keyboard. So in fact, even though they were all very different systems, on the outside they looked pretty similar. So they could all be abstracted. Their interface could be abstracted into what was hypertext. And I did not invent hypertext. Hypertext had been invented a long time ago, and Ted Nelson had coined the word. And it had, even though the Xanadu system had not taken off, partly because it had a certain centralized Ted Nelson controls the world sort of aspects to it, but also but partly because the internet had not been around. The ideas of hypertext had been around before, and they crept into a lot of help systems. So there were a lot of places where you clicked on things which were underlined or highlighted, and you got to other data. All right, so I didn't have to invent all that. I just had to notice that the idea of a hypertext page was a common abstraction for all these systems. And then, the idea that instead of in a hypercard system where a link can go to somewhere else in the hypercard stack, just to generalize that and say, actually, we're going to make a space of universal identifiers, which will actually be global and will give everything a global identifier. That was philosophically extremely difficult for a lot of people today, because it looked like a centralization. It is in fact the centralization of the web, the domain of the DNS, the root of the domain name system. But so actually, I am asking that, and so the minimum requirement is to use URIs. And it's still the minimum requirement. And I don't really mind which protocols you might use, but if you reinvent HTTP, I'll get it's boring. You're fragmenting the web, but you're not destroying it. But if you suggest that we shouldn't always use URIs, or you're going to start using the same URI to mean different things in different concepts, then you break it. So that's the basis of the solution. And this minimal constraint, you can look at as universality. So this is the universality of the web. It's got to be independent. It's got to be independent of all these things. Very important that it didn't You could use it on any software platform, any hardware platform, that it didn't matter which browser you used it for. And we had these big fights over that, because a lot of people wanted it to matter a lot. They used their browser. They find all kinds of ways of trying to, the best viewed using XXX browser. Do you remember those days? There are a lot of people who really earnestly put best used using a given browser. There were various different little icons you could get. And there was now most of the icons you see are best used using any browser. There was a sort of recoil reaction from the community, which was wonderful, which led, you click on those icons, it would take you to pages to say, don't do that. It really is important that your information is independent of the software. And I've pointed out that the museums should be right out there pointing this out. When you put your slides up in a proprietary format, notice these are HTML slides, and the pictures are, you can read that using standards. And I think that the standards will live. So information will be available to posterity if you use standards. If you use proprietary formats, then goodness, which tend to change, and they tend to not to be so well documented, then the posterity will have a problem, as well as half of your readers. At the time, there were lots of different networks. It ran over the internet, but actually there were URLs DECnet : which are just like HTTP, but they ran over DECnet instead of the internet, because there was a whole DECnet world, and there were gateways initially, but fortunately the internet wave was just sort of breaking. It just, the floodgates, somebody who'd been protesting against IP protocols being used in Europe, because the bastions of the ISO protocol stack, for those who remember it, somebody had taken their finger out of the wall, and the IP was rushing in, and it was sort of coming up to the knees already. So by the time the web came along, really I didn't have to argue about that. The DECnet : things disappeared after a couple of months, years, and they are gone. So IP sort of solved a lot of that problem. But one of the things which was very, very important was that the web really should not be a space for a particular sort of document. It shouldn't be a lot of documentation systems were designed very much for documents of a certain category. They were for storing technical reports or published papers, for example, or they were notepad jotting systems. Now, the wonder of the human endeavor is that people have ideas and jot them down, and then those jottings, you can see some of those jottings in the Computer History Museum, because they turned into computers. And you can actually trace through from the jotting to the document, to the note, which then became a proposal and became a design, and so on. And I think it's really important to be able to go up and down that, to be able to go back. We're going to change this. Oh, who put it in there? Why did they put it in? Let's go back to the meeting and find the minutes of the meeting where they decided to do it that way, because if we want to change, I want to be able to talk to those people to find out whether we're going to break anything. So I just wanted to be in a world where you had access to that information. And that means you've got to have in the same space the crummy information and the personal information, the stuff that you're not going to be able to read for 30 years. It's got to be in the same space as all the polished, beautiful corporate websites. And that affects the design a lot. It means you can't clone the system. For example, when the web took off, a lot of it was designed around this sort of author, create, generate, upload cycle, not hack in place. And the original web browser was a web browser, but you could put the cursor right in the middle between two letters and hit the keyboard and correct a spelling mistake and then hit save. So it was a browser editor, and that was the original idea, was that you should use the same software, and you should be in the same mode, no edit mode. Just while you're browsing the web, if you've got right access to it, you can go fix it, and you can add more ideas, you can annotate, and so on. We still haven't got there, and that's one of the things which we need to get to. Now, I was at CERN. It was a pretty international place, but it had a strong Western European flavor. So originally, HTML was ISO Latin 1, which was the best I knew. I didn't know about Unicode, and I'm not sure what state Unicode was in. With XML, we fixed that. So it's now Unicode, but actually, there's a lot more to making a system international than Unicode. It's amazing how you can build in a cultural system. When you're building a workflow, you can build in Robert's Rules of Order into a meeting management system, kind of assuming that's the way everybody runs their meetings, but maybe they don't. Maybe there are other cultures. It's amazing how you can make these cultural slips. So, not to mention wanting to go up and down the page and left to right. Internationalization is tricky, localization. They're part of making the web work for everybody, though. Another part of that is making it work for people with disabilities. If you really look at the number of people who have some form of disability, that is, there was an interesting talk somebody from Microsoft gave in London at a disability conference, where they looked at the number of people that, if you really look at people who are totally able to use the computer to the maximum, you find you've got sort of this. You may have less than half the people who are actually using it, because a lot of people, they have eyesight problems, so they're a bit jittery, or for one reason or another, they have to use some sort of accommodation. And of course, a certain number of people have to use very serious accommodations. They might be using a screen reader. And really, we must keep it as a universal space where people who have any form of disability can participate to the maximum. And this is actually really exciting, because the web allows you to do that much more than books and most materials have, because of the way we can deliver things in different forms. So that's really important. We've got the W3C, we've got the Web Accessibility Initiative, which is looking specifically at that and trying to make sure that, looking across at all the standards we're making, and just as a watchdog, and then working very hard to look at how you can make this web pages more accessible, and there are guidelines. And if you're making your website, please look at the guidelines. In some cases, it may be your duty under the law, but it may also be just your duty as a human being to do that, make it your site accessible for people as possible, for all people. Now, one of the techniques you use when you're making something accessible is that you separate the idea of what your data is from the way it's presented. That this is what SGML was about in the first place. There was a separation of form and content. The idea that this is what I mean. This is a heading. And the presentation is, this is pink 36 point. Right. Now, a lot of people, when they first started making web pages, they did it as though they were doing it with a paintbrush, and they just said, this must be pink 36 point. Wrong. That won't work on my cell phone. And it won't help if a screen reader is reading this out. It won't know how to pronounce pink 36 point. If you mark it up as a heading, that's useful. And if you go a little bit further, you don't mark it up just as a heading. You actually mark it up with what the data means. Never mind what the web page says, but the data here is, we're telling you about that the weather today in the Bay Area was 70 degrees and sunny, cloud level 0, temperature 70 degrees Fahrenheit. And you can just send those two numbers across the net to something which will, if you send them with terms which the machine can understand and then explain to you in whatever way you like. Read it out to you as you're driving. Put up pictures of a sun and for the kids, or read it out or write it out on the screen in any language. So that brings us on to machine processable data, because then when you've got that, not only can it be treated by a person, it can be presented by a person, but it can also be analyzed by a machine. I'm going to spend a lot of time talking about that. So the universality of the web is the most important thing for you that I want to get across to you. It's the sort of thing we must preserve for lots and lots of reasons. We will have to keep fighting for it for many, many years. And if that's all you'll be able to remember, then feel free to leave at this point. Okay? All the rest is optional. So now I'm going to take you back, though, if you want, to 1980, before the web. This is the rambling bit, this GIF was, of course, produced for an 80 by 600 display, and which, of course, I think I got zoom on, was. This is not device independence, but fortunately I can use accessibility options to show you what it looks like. So this is what the program Inquire looked like. It was on this is a character-oriented terminal. It would have been green on a black background. This is a thing I made 10 years before the web. Because there I was at CERN actually on a totally separate visit as a contractor. Found massive people doing all kinds of exciting things and trying to capture some of them. This is the concept of the PSB vacuum control system. I just point out a few things. One is that actually there's not a lot of text about this. There would normally have been text underneath the heading. In fact, all you've got are links here. The way you browsed this web was you typed in a number. You could also type other things. You typed N and it prompted number, I think, and then you could type one of these and then hit return, and it would take you to one of these other things. It was a mesh. The only way you could add to this, at any point you could add by saying, I want to make a new linked note, and it would prompt you for two things. It'd say, this new note, what's it going to be about? Is it going to be about and there'll be a finite list. You could be about a piece of hardware or software or a person or a concept, and a few other things. And it would also say, okay, so what's the relationship between what we're looking at here? This is a control system. It was described by, it describes this document. See, described, as you look down here after one, it says described by inquiry system. So that described by is the relationship between this concept and the thing whose title is the inquiry system. And this system includes the vacuum history system, which is another concept. So this thing was not just capturing what you typed in. Yeah, then you could type in any text you wanted. But meanwhile, it was sneakily trying to extract the semantics. What is it? Trying to get hold of the org chart, trying to get hold of the dependencies, trying to find out information so that you could answer questions. If this guy left the organization, then what would go wrong? Is there anybody in my team who has written a piece of software for which they have not written documentation? Now, this is sort of questions for if you're managing a group of people. It's a classic question to ask, and it's a classic question not to get an answer to. So, so the idea was, if I could get everyone to use this by making it a really, really easy thing, I could sneak this information, and then at the end of the 6-page manual, which I produced at that time, then there was a suggestion, and if everybody did this, wouldn't it be neat? Because then we could analyze it all. Now, actually, 10 years later, we made this was a 10-inch floppy disk, and when I left CERN at the end of my 6-month stint there, I gave it to some guy who was a system manager on the Norsk Data mini computers. The guy's name was Brian Carpenter. I didn't know he'd later become the chairman of the Internet Activities Board and many other things in the IETF, but at the time he was in between then, he was going to be one of the people who fought the IP viciously, trying to make sure that the ISO standards prevailed. But basically, we neither of us know what became of that floppy disk. So I've just got a few screenshots of the Inquire system. But when the web actually happened, notice that we lost the typing. We never when you make a web page, you don't tell the computer what it's about. And when you make a link from a page of a person to a page of the organization they work for, you don't tell the computer that this person works for this organization. And for 10 years, there I was feeling that this is a crying shame. So just to show you that was, I think all the time. When I actually wrote this is the proposal for the web, and on the front of the cover, I put the circles and arrows diagram. And the reasons for this are, one, I think normally using circles and arrows, if I didn't have this computer and the gap between us, and I would be drawing on the whiteboard, or if there was no whiteboard, I would probably be drawing on the walls. I find that's a very natural way of communicating, always different sorts of blobs for different sorts of concepts and different sorts of arrows for different relationships. You can express pretty much anything like this. So there I was trying to get across the gist of it. This proposal in the middle, it says, you probably can't read it back, but the arrows explains that this document describes the proposal, and there are various concepts which are related and unified by another concept and so on, and you can see there's an org chart down there. Now, there's a lot of our lives which is described by different circles and arrows diagrams. The web wasn't capturing it, but the idea was that information, well, it's captured for a human being reader, but it can't be analyzed. So that's what we have to. Work on. So to summarize the 1990 World Wide Web design is that there's these global identifiers, and having one is good. And so you should use one. If you're designing things, you should make sure that things are identified with URIs. And that's the main thing. And there are lots of URI schemes. Making them a new one actually is not a good idea. If you're a member of a company which has invented a URI scheme in the last few months, please go to the person who did, talk to them about it, and send them to see me if necessary. No, I'm kidding. No, but get them to talk to the URI coordination group about why. Why is that actually, every time you invent one of these, it's kind of costly. The whole community has to learn about it. There's one scheme which is HTTP you can use for a lot of things, which allows you to take, it defines a space of names of things. It allows you to dereference, it allows you to people to publish things and other people to look them up and get data. Allows lots and lots of data formats, and just as the URIs allow many protocols, HTTP really does allow lots of data formats, so it's much cheaper to invent a new data format than a new protocol. And so, maybe the person that you're talking about should be inventing another language. And so we've got HTML, and we've got HTTP, and for the hypertext application, which is using this information space to make a great big global hypertext, we've got HTML. And it's a global language for hypertext. It's pretty nifty for clicking around links and from your homepage down to finding recipes and things. But there's no typing in the links. That's the only sort of snag here. Just to mention what happened, this is a log scale. This is a log scale up there, vertically. This is the load on the first server, and you can see it goes over 3 years, from July 91 to, to about July 94. And one of the interesting things about this is this really is pretty straight. I mean, any biologist in the audience will say this is a straight line. It's remarkably straight. And also, the difference between the weekday, the blue hits are the weekday hits, and the red hits are the weekend hits. And that ratio, over 3 years, when we're going from, initially there were sort of 10 hits some days, going to when we had 100,000 hits, these ratios stayed remarkably similar. So there really is some exponential thing going on. Somehow, there was a certain proportion of the people who read our website went away and told other people to go and get browsers. And then they installed those browsers and then started reading the website. Somehow, there's a really strong exponential law. And that happened for the last those 3 years. And people ask me, when did the web really take off? When did it suddenly explode? And for a lot of people, individually, he came across it in 1993, 1992. For them, suddenly it burst upon them. But and they found one particular website which really turned them onto it, and they became aware of it. But you can see, for the folks who were there from the beginning, it was exploding. It was a sort of steady Big Bang, but it was continuing to explode at the same exponential rate, just a factor of 10 every year. And that's just on one web server, remember. Never mind the explosion in the number of web servers. 1993, a lot of companies were becoming aware of this, and I got a visitation once for a bunch of people, and for 4 people from Digital Equipment Corporation came into my office at CERN in Geneva, more or less unannounced, just called from reception, which was pretty unheard of. I didn't have a lot of visitors from the States. And they sat there around a table and said, look, we're re-engineering a lot of our company around this thing. We understand that it's based on some standards, and the standards are written on web pages, and the web page is on a disk somewhere, on a machine somewhere around. How do we get in the loop? How do we know when they change? How do we change them? How do we make sure they're stable? Could we have some sort of a group or something? So I chatted to them about what would be a good kind of group, and of course they had good feelings about the X Consortium, and they gently nudged me in the X Consortium direction. And I traveled around the States in '92. Larry Macenta arranged for me to stay for a month at Xerox PARC over here, and I stayed with Karen Sollins, was my host at Lab for Computer Science at MIT, and I talked in between to various people and figured out that we did need some sort of a consortium, and the industry really needed some umbrella under which to meet where they could rapidly enhance the protocols, but in a way that they remain stable. So this is the sort of the charter of the consortium, more or less. To implement new things, and to make new standards, very much to be implementation driven. When in W3C working groups, like in the IETF, if you've got running code, then it speaks volumes over the eloquent discussion of how things could be. We did set up the consortium to coordinate between groups, so whereas in the IETF and some other standards bodies, you can be fairly independent. We try to also have a certain amount of architecture so that the thing hangs together, and you can actually embed SVG in HTML. They're great standards, but if they can't use them together, it's a problem. Yeah, it's a problem. Some of these things are difficult. And we try also to keep these values of internationalization and accessibility. And we've also, of course, in those days, everything was royalty-free. You know, the internet was built, the FTP servers and all that was code which went up and people put out for free. And when we've had to formalize that, because now, after the big dot-com boom, there are lots of lawyers looking at this and lots of people trying to make a quick buck, lots of chances out there trying to maintain that they actually they invented all this before anybody else did. And even though, as you can see, the actual steps of invention behind this are really, really minuscule. They're just taking a lot of stuff that everybody knew how to do and pushing it a little bit in this direction, or putting it together with all this stuff that everybody else knew how to do. You know, HTTP is just a rewriting of FTP with some of the parameters changed. All that hypertext stuff had been done together. The idea of putting them together, well, a lot of people had sort of had the Gopher people more or less had that sort of idea. And so that, you know, if somebody suggested I should patent the web, I'd have probably laughed at them and said, "Go away, you know, it's all been done before. There's nothing novel in it." And in the way there wasn't. And with a lot of these software patents, there's really nothing seriously novel. Nothing you want to sort of write up and you go, wow. Apart from the RSA patent. The RSA patent is the only thing where I've sort of, you know, walked along a top of a windy hill with somebody explaining it to me and just stopped there in the rain and said, "Yeah, this is, you know, that is neat. You know, wow, cool. You know, that's one smart, you know." And even the RSA patent, when you look back at it, did the fact that there was a patent really help the deployment? Or why aren't we all using more public cryptography? Anyway, so we try to do things, we try to make sure that the things stay royalty free, because the only reason that you saw that graph, the only reason it picked up is because people in large companies and small companies in their garages went and installed web browsers and installed web servers and started to write their own web servers and write their own web browsers. And the only reason they could do it is because they didn't think that somebody was going to come along and charge them for the privilege of doing it later. Because they knew. In fact, it took 18 months, but Robert Caillou and I worked hard at the CERN administration and the CERN direction and eventually got something signed. April 30th, 1991, I think, a document which said CERN is effectively putting this in the public domain. And before that, there were some worries. And that's one of the things, in a way, that sunk Gopher. So there it is. There's the web. And for a lot of people, one of the concerns is that here we are working frantically to make it happen. And for a lot of people, they think that the web is done. And, you know, because you can use it, and it works fine, thanks. But what about those type links? What about helpful machines? Remember the idea of these computing machines? The idea they help us solve problems? What does your computer do to you? It brings your problems in the inbox, right? 100 at a time for you to solve, right? Does it help to solve them? No. Can't even separate out the spam. So, you know, the idea of the computer actually helping humankind is not visible in the web. And in fact, the goal of the computer is that, you know, we should, when you look at those slides, the idea of the web browser is to be totally invisible. You should feel that you're just in the space of information going from one set of bullet points to the other. You should never be aware of the computer, the fact that there's a computer involved, or the fact that there's software involved. That's the glory of the web, is the computer gets out of the way. It's got a very simple human interface. But that means that when it gets completely out of the way, and it just leaves you in sort of beautiful, harmonious communication with the author of that web page, then it's not helping you at all either. So now historically, what actually got us out of this, nobody really wanted to do the semantic web thing too much, even though I put up semantic web slides in the first web conference, which was back in 94 in CERN. But there was the metadata problem. There was need to catalog web resources and other resources. So there was a need for metadata. And actually, the resource description framework, RDF, is called the resource description framework, for its justification was metadata. And in fact, it was PICS. It was labeling things, being able to exchange information about which things were porn sites and which weren't. There was a big drive to show that you could make whitelists and blacklists, and you could make filtering software so you didn't need to have have federal censorship from Washington. You remember the time when Washington was going to censor all websites, even the Finnish ones, and all this business. And the internet was going to be, the routers were going to be made so they wouldn't accept porn and all that stuff. And we were trying to get over that by saying, no, you can just use information about information, and people can then filter things themselves. And that is one of the things that led to RDF. Now, what's different about RDF? A lot of people ask, so, what's the difference? I can do everything with XML. Can I do everything with XML? And of course, you do everything with XML, but when you write something using XML, when a programmer writes something using XML, use angle brackets, the program understands what the data is about. When you use something like Quicken or Money to handle your money, then the program has got built into it the understanding that that a transaction has got certain properties and what the relation and what they actually mean, what the total means, what the balance of a bank account means, and things like that. The computer hasn't got any idea, so a lot is left up to the programmer. XML, when you write an XML schema, you tell the computer about the format of a document. So suppose you're designing a form for registering a motor vehicle, and that you may tell the computer when you write the schema, you may say, the form contains a single field for the registration number, and that field, well, it will just have it'll have an alphanumeric value, and there will only be one field. And that tells the computer about that particular form. Now, the equivalent in RDF is that you can write something about the information you use for registering a motor vehicle, but you say a car has a single registration plate number. And you can pop in that actually it should only have one, and one number should only have one car, and one car should only have one number. And that is very, very reusable information. Any system that comes across a registration number anywhere knows that if it's a registration number, it belongs to a car, and also if it finds two cars that have the same registration number, it knows that they're the same car. Right? Now, when you're doing queries across a large amount of data, this is in fact very valuable information which you don't get from the XML document. When a computer reads an XML document, it has no idea what it's about. When a computer reads an RDF document, it knows a lot about what it's about. The clue is that you don't say car. People have been confused by the concept car forever. What do you mean car? Can it have 3 wheels? Does that have to run off gasoline? Well, the great thing about it is when you have a particular concept, like say color, it doesn't matter how you spell it. People have been arguing about what color really means. If you own example.com, then basically you have the right to define what this URI means. So you don't use the word color. You use a whole URI. And because you can get one of your own, you can tell everybody, go away, and not bother you because you're defining what this means. And if they want to use your definition of color, well, they can do that. And they can ask you what it means, and you can adjudicate, you can explain to them what it means. And you can put information on the web about what it means that they can go and look up just by putting this URI into the software that goes and looks things up on the web. And that's pretty nifty and pretty useful. But nobody's going to then have an argument. They can go and make their own URI for color. And later on, you might find you want to make some translations between them. Or later on, you might find, in fact, you're sharing a concept. And you can state that there's an equality of concepts, and that's very interesting. But using the URI is important. And I noticed that the most important thing about this URI actually is this hash here, this number sign. Some URIs have that and some don't. But when you've got one that has, the first thing that the machine does, the first thing that anybody would do with it when it comes to figuring out what this is about, is split it into 2 pieces. So the bit on the right is col, and the only thing you can do with that is put it in your back pocket. The rest of it identifies something in HTTP space. And HTTP, there's a registry of these things that says that, well, if you see HTTP, you go and look at the HTTP spec. And HTTP spec tells you what you can do with the rest. If you don't read the spec, you can't do anything with the rest. You're not allowed to peek in there and guess. If it says .html in there, then you're not allowed to assume that there's an HTML document or anything like that. I do not do that. This is completely opaque. The HTTP spec says you can go and use it with this protocol, and you may do that and get something back. And when you do get something back from that, then it may be in a document format. The HTTP spec will actually give what's called an internet content type or MIME type, You get the same thing with email messages. It says how to interpret this thing. And it may say that this is an RDF document. And if it's an RDF document, then the RDF spec will tell you how to go and look at what it says about color. And it may tell you useful things about, like about the information we had about number spaces. So you see, what we're doing is we're using this space of, which really is an information space. It's a space of documents, loosely. It's a space of information which we've built and we've used for hypertext. Now we're using it for new language. HTML was hypertext. Now RDF is language, not for talking about anchors and things you click on that lead to other things, hypertext anchors, but for talking about anything. And that's the semantic web. It's just using the semantic web to talk about anything. The way this works eventually is that when you've got your RDF document, you look in the RDF document and it says, oh yeah, hash col, that means color. And it's got a lot of explanation about it, but some from the machine, some for you. But that's when eventually you take out the COL from the back pocket. It's only when you realize that when you've got some information, actually you can talk about this thing as an abstract concept, but if you want to go through the whole network thing, then col only actually applies, it's actually treated by software when you've got something back and you know what language, what system you're talking about. So different languages, you can make completely new systems on the web just by inventing new languages, and that's a very important flexibility point. So now so here we go, Semantic Web 101, because a few people have mentioned that they'd like to understand what the semantic web is. It's very, very simple. Most of the data out there at the moment is in relational databases, and relational databases can be built up of these atomic units which relate something. They say that this column is all about a particular car, and this particular column may be about the color property. And this one particular cell says what value it is, that this car is red. So there's a relationship between the subject and red is, in fact, the color relationship. And that relationship between two things, that's equivalent to the good old circles and arrows. Remember the circles and arrows? This is a talk about circles and arrows. So, again, we've got these three things, the subject, the relationship, and the value. Car, color, red. You can put everything in that form. You can encode this stuff in XML. The RDF spec tells you how to do that. And it's nice and simple. And you could, for example, you have a table of data, a rectangular table, and you can think of that as circles and arrows. You can think of that as the relationships between, for each thing, this car has, for this property has this value, and this property has this value. You can turn it into circles and arrows. It's a kind of boxy circles and arrows diagram there, but of course, great things with circles and arrows, you can do trees too. Remember, each of these, the blue arcs, are colored with a particular blue which indicates what URI, what we mean by color here, and all the blobs are identified with URIs too, so you can go and look up information about them. Because they use URIs, the really nifty thing about this is that if you've got one piece of data and another piece of data and they use the same URIs for the same thing, when you take, say, your graph from the table and your graph from the tree, and you load both of those in at the same time, they can overlap. So actually, you merge these data, the merging of this data happens very, very naturally. That's one of the first powerful things about RDF. You get data from over here and data from over there, you just throw it in together. You just basically concatenate it, and you end up with this. Now, that picture, it's not a table, it's not a tree. Tables are really easy to deal with, and trees are really easy to deal with. And people like to be in tables and like to be in trees, but the big world out there is full of tables and trees. And actually, when you look at the tree-oriented data, it's like the original documentation systems. Everybody has their own tree root at a different place. Everybody thinks about things starting from a different place. They categorize things, yes, often in tree things, but if you look at the way people design the folders on their computer, for example, or they organize their mailboxes, everybody does it differently. So if you take all the trees and you superimpose it, you end up with a big tangle. So whatever you use to represent knowledge has got to be able to represent big tangle. So here's some circles and arrows from a blue RDF document. It's about a person attending a meeting. And if you might read a green and a red document, and then you end up with more data. Merge just like that. You try doing that to an XML document. If you want to merge two XML documents that come from different applications, first thing, yeah, sure, you can do it. The consultant will do it, okay? And the consultant will first go and interview the person who made the first XML schema, and find out what they meant by all the fields. And then they will interview the person who made the second XML schema and figure out what they meant by all this information. Then they will try and figure out how the information on one relates to the information on the other. And then they will invent a third XML schema for expressing the result. A new document type which can include both sorts of information. And then they will write an XSLT script, which will take, they will customize for taking information of type A and information of type B and merging it and generating information of type C. And that's really straightforward. XSLT is a nice programming languages, and you only have to do this for every pair of applications in your system. And and there are plenty of consultants out there who will be happy to do it for you. Whereas with RDF, you just concatenate the files and you're done. Now remember I mentioned that the properties in the table, they're identified by URIs. When I merged those graphs, we saw what happened when you merged when you had an individual, a person who's identified by the same URI. What we're doing here is we're looking at the property. Do you know how many times people create new databases and they talk about zip codes? Like all over the place, there are people producing databases which have got zip codes in there. And does the computer know that they're all the same concept? No, it doesn't. They call them zip. No, if the computer relied on anything being called zip, being a zip code, it would be a disaster of the highest magnitude. But so what happens in the semantic web is first we say, go use completely different identifiers. And then when you know that they happen to be the same thing, say so. So you have an RDF triple which says zip here is the same as zip code there, and we mean the same. And then a query which you used to do in this system can be converted into a query on this system, and later query on the whole semantic web. So you see that what's one of the fundamental ways about how the semantic web works is that people they're thinking of concepts. These are hard concepts. These are things that which describe the way their computer programs run and their ATM machines run, and describes how the properties of bank statements they get back from the web. And when people do that, sometimes a person designs a few concepts just for use during an afternoon and never tells anybody else, and then forgets all about them. And sometimes a person tells a few of her friends, and they end up using it and designing a local application which uses it. Sometimes they realize that, actually, this is latitude and longitude. Surely somebody else must have thought of a URI for this, which we could use. And if we did use it, A, we wouldn't have to write the spec. B, we'd be able to interoperate. Our data would be able to interoperate seamlessly with anybody else's data which used latitude and longitude. Now, latitude and longitude, of course, is a great, mysterious, and extremely deep subject. But, people carrying GPS, but there's a lot of work being done on it, and there are a lot of people who actually use, the sort of latitude and longitude which you get out of a GPS device, and they exchange that. And for something like that, for something like feet and inches, perish the thought, or better, please, meters, when will you guys get around to using them? Then it is really valuable to have some global standards. And anybody who's tried getting involved with them knows that global standards are extremely painstaking to make. They take a long time. You have to get a lot of people, bright people, to compromise. And so they're expensive. They take a lot of time. So that you're not going to have them for everything. So that's why we're going to have the semantic web is going to be a very rich mixture of lots and lots of local concepts, lots and lots of medium-sized concepts, enterprise concepts, and a few global concepts. It's going to be a big, interesting mix. It's going to be fractal. It's going to have interest on lots of scales. I tried lots of different ways of doing this. I tried explaining how applications connect through the common concepts. I tried crossword diagrams and three-dimensional diagrams, and I ended up with the good old Metro map. At a science museum, you can now buy a book about how Mr. Beck designed the London Underground map, and how his design was rejected as being this topological design was rejected, and how eventually it got picked up and then became loved by all the people who used the London Underground, and there's a whole story about it, but would you believe? And here, I'm using the lines are concepts, like, for example, latitude and longitude is the green line. And in my address book, I note down that a certain person, people, the concept of people is the yellow line, is at a particular address, and I might put a zip code down, and that zip code can get me an approximate latitude and longitude. So, actually, from my address book, I ought to be able to draw a map, a large-scale map. If you look at information about an event like this, actually, that deals with all kinds of things. It was actually, it was free to come in, but this one they didn't charge for, but it's information about events often has information about people speaking at the events, about when it's happening, and about where it's happening. So it connects on the timeline. And these are the things, these common concepts are the things that will make the semantic web work, being the fact that you can get from one application to another by going through these lines. So one of the things I want to do that frustrates me, one of the reasons why I desperately want to make the semantic web, just as I desperately wanted to make the web 10 years ago, is that if I take a photograph album, which I've made using one of the, there are a bunch of sort of pieces of software for making photograph albums on this machine. If I take one of those photograph albums, drag it by its icon, and drop it onto my calendar, what would I expect to happen? Well, of course, the wise amongst us would expect nothing much to happen. Sort of boing, bounces off or something. But now what should happen? Well, if we take a lot of information about photographs and drop it onto the calendar, what could happen is that the calendar looks and says, ooh, lots and lots of RDF, lots and lots of stuff. Can I have that in RDF, please? Thank you. So it goes to the clipboard and says, can I access that in RDF clipboard type? Comes back and says, ooh, don't understand shutter speed, don't understand JPEG, don't understand, ooh, understand date time. Oh, this has got a date time, it must be an event. No duration. Well, 60th of a second, I can't show that on the calendar. But I will take this as a point event, so I can display this as a point event. So I will just give it an arbitrary icon. Oh, it's got a little icon. I'll do that. Oh, that's good. It's got a small icon. So it's got a description. Oh, I can make a nice event out of this. I understand enough about it to turn it into an event. So the nice thing is that there's a quick negotiation. That the thing is that can I have that in RDF, please? The calendar absorbs it and sucks, finds a circles and arrows diagram with lots and lots of information it doesn't understand, but extracts from it enough to be able to drop little icons, maybe even little thumbnail sketches for all the photographs I took all over the month in which they were taken. Now that's useful. And in fact, there are lots and lots of really, really useful things that the computer ought to be able to do. When you enter this, you're at the web page for this event, and what do you actually have to do? If you're using a computer, it's on your laptop, you found the web page for this event, and you make the one-bit decision, I'm going to participate in this event. So what do you do? Well, what you do is the first thing you do is you cut and paste, you copy the information about the event, and then you go to your calendar application and you remember when it was in your head. You go to the calendar application and you manually scroll through. This is where I always make the mistake, put it in the wrong year. And you scroll through and you try to find the right time, and you hope that you got it in the right time zone. So, and as you scroll through this stuff, and you open a new event, and then you paste in the description which you got from the web page. Now, on that web page, there's also there's information about where it was. Maybe you'll cut and paste that in. Maybe if you really want to make this system work for you, you will copy the address where it is, because you're going to use your GPS to find your way around this strange state, and so you're going to you go to one of these map sites, and you can't paste in the address exactly, but you actually have to paste it in a little bit. You have to put the street in here, and the city in here, and the state in here, and then you say go map it, make a map, and then you get a map, and then you know that there are some of these map sites where they still have the latitude and longitude on there if you go into the right mode, and you find the latitude and longitude, and you get a piece of paper. And you note down the latitude and longitude on the piece of paper, because when you get to your GPS, as you leave the house, you pick up your GPS and you've got these 5 buttons, right? And it's got a USB connector on it, but actually you're going to use the 5 buttons to put in the latitude and longitude so that it can show you where to go. Now, you got your address. Your address book knows when you're doing. Sorry, did I say address book? Your calendar knows when you're doing this. The address book should know about all the people. There's a list of all the people organizing the meter. Do you copy those in? No way. You're exhausted by this stage. So you print it off and you stuff it in your back pocket. And when you get there and it says, and you really need to know who it is, it says, click for organizing committee. You go, rats, I didn't click before I printed. So there was this one bit thing. What should you have done? You should have said, I'm going to go to this. And the computer should have sucked off the information should have gone to the RDF version of the page. And said, all right, give me this in a form I can understand. All right, this is an event. In fact, the moment you browse this thing, it should have picked up the fact that there's an event here. And so a little thing would have popped up, maybe not the horrible paperclip, but assistant of your choice would say, your semantic web friend will pop up and say, an event, and there's a couple of buttons. ignore, or participate. And you hit the participate button, and then you've got rules. If I'm participating in an event, then during the time of the event, from the start to the finish, I am at the physical location. And the machine will immediately, that will therefore, the machine will know to put in your calendar. It will know at the particular time to put in your GPS. It'll know to ping you a suitable amount of time beforehand, etc., etc., etc. So it should be just a one-bit click, and that computer's got all the information, and you have to do it instead. So that is, as Dan Connolly says, doing things that, when I have to do things that the computer could do for me, that is the bane, he says, it's the bane of his life. That's why he's working on the project. So semantic web works by connecting things. I just found out one more thing before we leave this slide. The pink line. In this company, the customer relationship management, the CRM, and the engineering team share a concept of part numbers. Which part number have you got? And the catalog tells people, which is public, uses the same concept of part number. But frankly, the concept of part number and some of the information about the parts, really that's company local. So a lot of these concepts, as I said, are going to be company local. They're going to be enterprise-wide. Some of them are going to be personal, but a lot of them are going to be enterprise-wide. They're not all going to, some are going to be restricted to particular communities like the tech community, where some of that may be physical data, maximum operating temperature, which general public wouldn't be so interested in. So there are lots and lots of layers. And some of this information is private. The address book information is generally private. The event information was public. Maps are a mixture. The parts are enterprise-wide. So we're talking about, yes, it looks like one great big semantic web, but in fact there's a lot of granularity, there's a lot of richness to it. There are lots of, different bits of it have different access patterns, some bits of it you're less likely to believe. It's this great big fractal web of concepts. It's working across all kinds of different boundaries. And that is an important thing to grasp about the semantic web. Initially, when I started describing it, people assumed that it was just going to be one huge, great, big mathematical equation defining all of humanity. Well, that's not it. It's a whole lot of different documents which have very, very different statuses. And the tension between making the local sticking with a local standard and not talking to other people, and going and trying to get a global standard will always be there. That's just part of, it's part of the development of cultures in society. It has been since, but the development of language. It always will be. It's a very important part of how society works. So society always will be that fractal tangle. So the semantic web must be able to represent that, so that part of being universal space is it must be able to represent a great big mess. And it must be able to operate on different scales. Your life is a web. Your data will be a web. I presented that last bit from your personal point of view, but when you look at where the web's actually going to take off, people ask what the killer app is going to be. And I'm sorry, there's not going to be a killer app. The whole point about it is that it connects applications together. It was like trying to sell somebody on the first web, by showing somebody a wonderful web server. It was never going to work. The exciting thing is being linked to lots of other ones. How's this thing going to take off? Well, one of the areas might be in the enterprise. Enterprise application integration is currently a huge problem, number one. There's a lot of people understand how much money they're spending on solving it. They're writing lots and lots of these little XSLT programs. Every time they want to connect two things, they write one of these. They put some consultant effort in as one of these yellow blobs. So what RDF offers is a sort of hub system which allows you to just once convert each system so that it will output RDF and input RDF, and then you can operate much more easily within this single RDF system. And currently that is the way RDF is being sold to the enterprise. This is the way you can avoid the huge cost of enterprise integration. Obviously, with time, you want to take out those yellow blobs. The next time, if it costs you money to write a yellow blob, next time you make your catalog so that with a software which just works in RDF, and the yellow blob disappears, and everything gets much easier. So when you're building an enterprise system, and you're integrating these things, ask for RDF. If you don't ask for RDF, you'll end up with a system like this, but where the central thing is a proprietary node that's been put in by your enterprise application integrator, and they will own how that works. And if you want to fire them, they will take it with them, and you won't have your data. So you have to ask for your data back. You have to say, when you've integrated all my stuff, will I have my data? Will I be able to read it? Will it be an RDF? Okay, try asking that. Because if you do get an RDF, if they humor you and you give it an RDF, then as the future becomes more and more RDF-y, and as there are more and more people who do this, you'll be able to just trade these things, and the whole system integration thing will become a vanishingly small problem anyway. Vanishingly small. There will be integration tasks, but they will operate at a much higher level. There'll be a huge set of these tasks which will disappear. And of course, the real reason, if you're here, then you're probably interested in the history of computing and where it's come from, where it's going to, and you'll probably realize that the really exciting thing actually is not using RDF within your enterprise. The really exciting thing is that if everybody does that, then you'll be able to connect to everybody else on the great big RDF bus. Right now, you can't sell this now. This is not a reason for putting RDF into your enterprise, because there's nobody else on the bus. And just like with the web, I initially had to sell it as CERN, a way to get at the CERN phone book. And it was written up in the press at one point as a way of a strange way of getting at the phone book data. But you have to justify it. You have to find a way of making this work out as regards to the bottom line now. So now we've got, with the semantic web, we've got the design, and we've got the bottom, and it's just the same old web, right? But you notice that we've got bottom two, we've added another dot. We've got HTML as a language for hypertext, and RDF as a language for data. The data in our lives. Actually, there are lots and lots of languages that deal with this. RDF is the bottom layer. When you describe the concept, that's called making ontologies. It's a kind of fancy word, and it's got a lot of other meanings, like most words. But this is sort of an embellishment of RDF schema to make it a more powerful way of describing how the concepts relate. And the next thing we're going to standardize is the rules language on top of that. And it would be very nice if we could have a logic framework which allows you to take all the different rule engines and write down the axioms and explain how each of the pieces of the semantic web worked in, say, first-order logic, or some other more complicated, horrible modal logic, or whatever it takes. And of course, the moment you get into this area, you get an awful lot of logicians, and not to mention philosophers, arguing about sort of where exactly this fits in the philosophy of mathematics and logic, and whether it's all possible. So the green piece I'm not going to hold my breath for. It would be exciting. But the blue piece actually we can do on top of rules. The blue piece says that a lot of the algorithms that people will develop on top of the semantic web is going to be a very exciting space. There will be a huge number of really exciting new applications that people develop once there's this amount of data out there. And some engines will have really weird ways, fascinating new heuristics for ways of finding the answers to questions. And not everybody will be able to do that. So you might go to a system and say, hey, this guy's walked in with this credit card. Can we use it? And the system may use some heuristic to try and find why we should trust this person. And eventually it'll find a train of trust. And then it'll come back, and the poor old till couldn't have done that. But the till has to make an informed decision about whether to actually let the person walk away with the can of beans. And so the system will then say, well, I can prove it. Okay, this is what I found. Okay, here is the digitally signed certificate from his bank. Here's the digitally signed relationship between our bank and their bank. And here's the digitally signed set of rules which you, the till, were bootstrapped with when you turned on this morning. And you see, according to those rules, everything fits. QED. And the till being just a till to see step 1, step 2, substitute JBogs for person in step 1, take step 1, modus ponens, and substitute into line 3, QED, he gets the beans. Yeah, and you go, bing, ching, and that allows these very complex systems to be able to actually be checked by very simple systems, allow the systems to be secure, even though they've only got a little bit of code inside them. So building trust on top of this is really exciting for the future. But that's kind of researchy. In fact, when you look at this is the same stack, and I don't know whether you can see it at the back. Maybe try this blowing it up thing a little bit. No, not that much. This is the same stack of web, but across the top, you can see all these things have to move from research into proposed standards, into web standards, and then into wide deployment. And as you go down sort of the middle column there's sort of, you can see there's XML on the bottom and RDF. All these things have to move through that. So the blue wave, which you see washing across the beach here, is where, when we started the semantic web activity, we were. XML was pretty well deployed, and it was giving us, as a result, interoperability within an application. And RDF wasn't deployed, really. There were lots of RDF-like things which had happened which were not web standards. They'd been proposed standards, but they weren't webized. But we didn't have RDF. And since then, RDF has really got into a lot of things. It's got very well accepted in the specs, been through a second revision. It's out there, been out there for a long time. There was nothing in Ontologist when we started. The ontology work was really where we got going in the standards community, and that now is becoming standard. The working group's getting done with that. They want to move on to the next thing. You can look at this so that the wave now, the white wave, is where we are more or less now, or we're yes, more or less now. So, looking at this, you can see that if you're going to do research, it's to do it in trusted systems and the more fancy logical things. That if you want to do standardization, the thing to do is rules and query. If you're going to work on getting the stuff out there, then work on OWL. Because OWL has been standardized. Now it's a question of using OWL as the ontology language. It's the web ontology language, sort of in some order. And so it's happening. This, the wave is spreading across there. I'm not going to predict when we'll get to, where the wave will be in 5 years' time. There's lots of things we want to do. I shouldn't have to go over this. You can imagine that there are millions and millions of things you want to do with it. What people have asked about, though, is what's going to be difficult. Why hasn't it all happened? Well, one thing, standardization with so many people clearly involved, or lots of people interested in this, and doing standardization across that is tricky. There are complicated things logically that you need statements about statements. And when I talked about using first-order logic, if you allow statements about statements, which is metadata, data about data, which is really core to a lot of this stuff, it's where it started. That's sort of incompatible with first-order logic because you end up with paradoxes. So actually there's some tricky problems here from the research point of view. One of the problems is people thinking that we're done. We can use the web, we can click on stuff. And the other problem is that with the snowball effect, that there were 3 phases to the web. And there were just the same three phases of the semantic web. Right? The first phase of development of the web was that, by the way, there are not really 42 slides, you'll be pleased to know. The last ones are dummies. The first phase of the web is, why should I use a stupid syntax? Why should I use HTML? I hate your syntax. I've got a better one. Why should I use RDF? I can do everything with XML anyway. I don't get it. Third stage is, okay, you persuaded me to use HTML, and okay, so we're using it, so within our enterprise, within our group, we've got these web servers, and hey, it works, yeah, okay. No, and we're using the common tools, and everybody can use the same web browser, and yes, we've managed to get some data, we've done stuff and analyzing this, our human resources data, and in combination with our bug tracking data and our parking lot reservation system data, and we've done some, that was nifty. So okay, I'm not regretting the fact that we started to use RDF. It's a reasonable language. And the third phase in either the system is, oh my goodness! Do you see what it just did? Did you look what I typed in? Did you see what it just did? I can't believe on this machine, it's as though it's got the entire planet on my laptop. With the web, it was, hey, you can get airline tickets on this, or you can get the Vatican exhibit. And with RDF, it'll be, you mean all that financial information about the savings and loan disaster is available there, and I can check for whether we're going to have a savings and loan disaster. I can run my algorithms, and all that NASDAQ data is right there. That's awesome. So that when these things actually start to connect, you get the wow effect. But you can't sell it on the basis of that. No, we're still pushing the bobsled. There will be a time to jump in when it's moving, and we're getting there. It's starting to pick up speed, and we'll just have to jump in and steer frantically. But with all these things, there is a time. There are lots and lots of threats. If we do it wrong, to put it simply, patents. I won't go on about patents. Software patents have done a lot of damage. They've done a lot of damage to web standards. It's not real ones where some inventor is really being rewarded, but the cowboys And the fact that, and the nuclear stockpiles, the fact that large companies keep huge amounts of them, just in case one of those cowboy companies comes out of the woodwork and threatens them. You've got to have so many patents in your portfolio that they won't even think about it. They won't even dare. It will be too horrible. And when you've got a situation like that, do you remember what that, the stockpiles were like? When somebody just says, there could be a patent problem around the P3P standard. Have you ever seen a room empty? Really, really fast, and stay empty for 2 years we've spent $150,000 getting a lawyer to make a statement that says, bullpucky. There is no problem. That patent does not apply to that standard. 2 years? This was during the dot-com boom. This was the privacy protocol, which wasn't really, most people just wanted as a hygiene thing. They wanted people to be happy about privacy as they browse websites. They just wanted the privacy preferences panel to work on websites so they could go shopping. People go shopping happily and spend more money. And the patent was demonstrated to be a nonsense problem, but the fear, uncertainty, and doubt is what does it. And it stops the investment, and it stops the standard taking off, and it destroys all the new markets that you're going to build on top of it. So it is economically a disaster. So we've worked really hard, and now the W3C has got a policy by which people, one by one around the table, actually all together, in synchronism, say, royalty-free, this standard, for doing this, I will if you will. Will you? Will you do it royalty-free? I'll do it royalty-free. Will I do it? Yeah. Will you do it? And sort of everybody turns their cards over at the same time, and so they go through as the spec goes through the process. People can back out and say, "Oh no, we didn't realize. We actually there is a patent here," and you can start to negotiate and figure out what to do about it. So there are exceptions and things, but basically there is an understanding that we're going to try to make the foundation for the next generations to be royalty-free. And that's and this is very important. Another threat, of course, is that you all go out there and say, hey, semantic web is so cool, I'm going to go and buy it. And you go down to a sort of software store and look on the shelves and don't find it and get upset. So keeping the expectations right is really important. I've gone about how you should use the web enough. I'm going to close just saying that this technology of the web has been good fun, but the really important thing has been that it's been great fun doing it with people. Initially, when I originally made this web browser thing, it was a web browser and a web editor, and it ran on Nextstep. So I sent it around a news group for people who used Next. And there weren't that many people. Unfortunately, it was a dwindling number as time went on. And I sent it around a news group of people who are interested in hypertext. Alt.hypertext, an alternative news group, how humiliating. And and then I sent it around among the high energy physics community, because after all, I had to persuade them because they were kind of paying my salary. So, and it spread in those sorts of ways. But then the word got out, and some of these wacky people on the alt.hypertext groups, they send me emails in the middle of the night, their time, and saying, before I went home, I just installed this web server, and I put some silly photos on it, or I put a dinosaur exhibit on it, or I put check it out. And I kept initially a list of all the web servers, of course, which you need to do in the early stages. There's a list of all the semantic web ontologies, which you need to do in the early stages, but there won't be in the end. And the spirit of all these people just working together and throwing stuff in, and the fact that a lot of times you wouldn't meet them for 3, 5, 15 years, but you meet people who'd actually had been a part of it, and you could just sort of see the twinkle in their eye from the email which came across. Thought it might be a sort of nifty idea. Thought this would be kind of cool if we did this. And in fact, they've done something. Steve Putz at Xerox PARC made the first map server. He had some free census data, which he'd been playing with for another project, and he made the first dynamic map server, which you could zoom and pan, all the stuff like all these commercial sites based on that. He did it really early on and demonstrated, and there was this huge aha, ooh, yes. Now, a lot of those websites were actually virtual websites. They were generated by programs. People didn't realize that until they saw the map server and realized that, this can be dynamic. And then all kinds of interesting virtual things came out. So it was a great community, and it still is. The exciting thing about the semantic web is that the big companies, some of them are actually attacking it, and some of them are a bit confused about it. Some of them are a little not quite sure what to make of it. So there's some small, medium-sized companies that are totally committed to it, and there are a bunch of people in their garages again. Just as we have this 24/7 chat session for the IDF interest group. It's on irc.freenode.net. RDFIG channel. And you can get answered questions any time of night. And when you can just ask a question about whether, saying, wouldn't it be nice if we had a bit of software, and 24 hours later you'll go back there and somebody will have made it. And it turned out when we had the first get-together of those people, it turned out that one of the people was actually 14 years old. We had no idea what in the WTC working group, what do we do when we got a minor? This guy had been really productive. He set together small, committees, and he'd produce software, and he'd organize people to discuss specs. And we didn't know whether we had to call his parents, or did we have to get special insurance, or what? No, but he's been a great part of the spirit of it. It's been the spirit of the internet and the spirit of the design of all this, which has just been wonderful. And remember when you look at these sort of these metal hulks out there, just get hold of the stories of all the fun that everybody had putting this stuff together. It's been awesome, and I think it will continue to be so. And as I said last night, it's because when you get hold of a computer, when you get a hold of the network, then you start writing programs. It really is absolutely left completely up to your imagination. You didn't need to take notes. These things will all be on the web the moment I've checked them into CVS. So remember that the data in your lives is a web. Remember that this whole space is fractal. Thank you very much for your patience and attention and listening for such a long time. Now we have time for questions. Thanks for your attention.
We're going to alternate two people giving mics out. Please say who you are for the record.
Thank you. I'm Gary Gray, and listening to you is like listening to Buckminster Fuller. Lots of ideas. My question is, when you talk to Linus Torvalds, if you ever talk to Linus about...
Have I talked to him face to face?
When you talk...
Changed email? I don't think so. I don't think Linus and I have actually chatted, as far as I can remember.
Oh.
But
well, my question is, if you did talk to him about technical things, what would you talk to him about, or what things would come up? Now, maybe since you haven't, it doesn't.
Well, probably. Oh, this would be like Guido van Rossum and I thought early on when he was creating Python, and I was creating the web. And so he said, "Hey, I got this new language," and I said, "Can you make a web browser out of it?" And he said, you're making web browsers? Why don't you make them in Python? And so we spent a certain amount of time. He did make a web browser in Python, actually, he tells me. And now I'm writing a whole lot of stuff in Python. I do everything in Python. So he probably, I don't know what he tried to persuade me to do, but I'd probably suggest, we'd probably talk about the GNOME desktop and the way it's using RDF and the way, in fact, building the RDF into the operating system is an interesting question, or at least making all those configuration files. I'd probably first nail him about etc. config files. And can we start moving all of their multifarious formats one by one into RDF? And I've got this nice N3 format, which is a much easier to read and write format than the XML serialization, which is totally equivalent to the XML serialization. I'd say, hey, how about getting using N3 for some? Let's start moving. Let's start a cult of writing all the config files in N3 and all the metadata files within the operating system and so on. So yeah, probably try and sell him on the semantic web stuff, and I don't know what he'd try and sell me on. He'd probably tell me I'm using the wrong operating system, but I use Linux a lot. Anyway, and I'm using Fink, if anybody's into that sort of thing. So I'm pretty, really, using a lot of open source stuff here.
Hi, my name is Omar Beg, and my question is, your development of the web, it's really changed the world. And what I want to know is, what aspects of your life most contributed to doing that, and was there any personality trait that also was very key in that whole process?
A, luck. B, luck. C, luck. Being there at the right time to a large extent. If you look at Doug Engelbart. He did the whole thing. Have you seen the video of him running his machine? He's sitting there, he invented the mouse because it hadn't been invented before. All right, now I didn't have to do any of that. He didn't have, so he did the whole thing. He did it on a single computer because they didn't have network computers in those days. But he had hypertext email. He had hypertext, databases and things. It's an awesome thing. And was it a vector graphics display? He did it. There's a great video of the demonstration that he gave, and you'll see that actually he'd done it all before. Go back and read Vannevar Bush's article about the Memex. Okay, he didn't even though he was funding the development of computers and stuff, he didn't actually realize how they could be involved and did the whole thing out of photocells and mechanics. It's like a sort of photoelectric Babbage thing which would retrieve information. So I happened to be in an environment like CERN. I was very lucky to be working at CERN, which was heterogeneous, had a serious documentation integrations problem in spades, had a very heterogeneous environment, was a sort of microcosm of the world from the point of view of trying it out. It was like a petri dish for developing a new culture. I was very lucky to be working for Mike Sandel, who looked at my spec. I ignored it for a year, but I wrote. Mike, unfortunately, has passed away since. But somebody found his copy of my original proposal, and the one with the circles and arrows diagram, and on the top he'd written in pencil, "Vague but exciting," and. I was lucky that he had a twinkle in his eye when he said, "Hey, you want to buy one of those Next machines? Why not? And why not try this hypertext project out? Why we got to try? You've got to try something. We've got to test them out somehow." So it's being in the right place at the right time. Personality trait: probably not resisting the urge to tell everybody what to do. I think not trying to control the universe is probably important. I think a lot of systems. Even now, since the web, people have come to me and said, "Hey, I've got to tell you about this great integration system." Well, we come into the company and we suck all their data into our system, and then we can do anything with it. I say, okay, just suppose, where you're from Australia. Okay, now just suppose that somebody in France had invented just the same system, but they'd invented it, all the same philosophy, same idea. You walk into a company, suck in all the data, put it in their system, and do anything with it. Supposing they'd done that, but all the arbitrary decisions, like what to call the tags and which network to use, and which all the actual arbitrary decisions in the design, they'd flipped coins and come up with a different design. Supposing some company had got their system, they were thinking about using your system, or they'd used your system, and then they came across this system, or the two companies used different systems, and they merged. What would happen? And he says, "Oh, easy. We just swallow up their system too." No. That's failed the test of independent invention. So I think realize this test of independent invention is what happens if you meet a system just like yours but different. Does one of you have to be top of the pile? Because if so, it's not going to work. It's not going to scale. It's not going to be web-like. So I think that was the experience when people try to make systems which were too constraining, which was also being in the right place at the right time. So hence luck and luck really, and the luck to have had just come across an amazing number of people who have put incredible amounts of ingenuity into it, and it also found had a lot of fun out of it. I believe that all people are fundamentally wonderful, and everybody has got ways of contributing in different ways. So in a way, if you want to put me up there and make a hero out of me, I'm going to resist that. I'm going to say, no, you have to make a pedestal, you get on it, and put all these people up on it too, because everybody's contributed in different ways, and what looks pivotal, it just depends on your frame of reference. So no.
My name is Paul Borrell, and my question is, why did you design links on the web to be unidirectional? In other words, clicking from one page to the second page, there's no implicit way to click back from page 2 back to page 1. Right,
because otherwise it wouldn't have worked. That's
Can you say more about that?
The question was, why are the links monodirectional? So consider a web. There are lots of hypertext systems. Almost every hypertext system which had been built until that point had bidirectional links. And in fact, it was a credo that when you build your CD-ROM of your hypertext presentation, that there will be a central links database. It'll keep track of all the anchors. It'll know which of them lead to which, and it will make sure that you don't get in, that everything connects. That if there's a link going that way, that you can also find your way back. In fact, that's one of the added values that a hypertext system gives you. That if you make a link to something, then you've got the extra information when you're at something that actually has been referred to from here. Now, of course, you can do that as a second order thing on the web, but fundamentally as a first order thing on the web does not require that the link goes in both directions, because if the link goes in both directions in a distributed system, it has to be stored either in both places or at one central place. Most hypertext systems use one central place. If you store all the links in one central place, this has the advantage of making me the ruler of the entire planet, because I can always charge you for storing them. Okay, it has the disadvantage that I will never ever keep up. And of course, you won't want to make me king of the entire planet and pay me 10 cents a link, so you won't use it anyway. You'll set up lots and lots of competing centralized systems, and because they're built to be centralized, they won't interoperate, so there'll be lots and lots of fragmented webs, which in fact was kind of the system beforehand. So the decentralized system doesn't work. So why don't you store the information at both ends? Well, that in effect is much more appropriate. But both ends, the ends are very, very different. You can actually, of course, use one of the search engines to find lots of incoming links, and you can build. A lot of the blog systems do this. With the talkback features, they allow somebody to register, I got a link to this, and to build the backward links. But to do that, you need some social understanding. Can you imagine if automatically, every time somebody made a link to the White House page, the White House had to make a note of it, acknowledged it, and before that link could exist, there had to be a protocol across the net which would acknowledge it and store the other side of that link on the White House page. Well, actually, the White House is concerned with lots of things, but they can't afford to keep track of all the people who link to their page. So that it wouldn't work socially. And also, even if you did do that, you're storing the same data in two places. Okay, anybody here designed a database system? What don't you do? You don't store the same information in two places. Because the first thing that happens is that you make the assumption that it's the same data. Second things that happen is one day it isn't, and the whole thing falls over. So so you can't aim for this consistency. So error 404 is why the web works. I'm sorry, that's the sacrifice. So if you want the answer of why the other question, why does the web work? It's because it made the sacrifice of allowing there to be error 404s. Sacrifice totally.
My name is Kurt Gowan. Sorry to yell.
Where are you?
We could use a little heat from those vacuum tubes downstairs. One thing to add to your list of challenges is how messy real-world data is. I was just thinking about what I know about car license plates and how car gets wrecked and the plates are moved, or the front plate is stolen and gets on another car. And so I think that's the other thing to add to your list of challenges.
Messy data, messy, that's true. And in fact, that's why, and I'm really trying to get people to use the semantic web on the very clean areas. So representing things where you've got a very clean, like bank statements and things like that, where the data, or GPS readings, where you've got pretty well understood bounds on the data, and the meaning is, and yes, using it for, when people start trying to use the semantic web for things like whether somebody is polite, or or fuzzy things, or they start hauling in data which is dubious from doubtful sources, then obviously you have to use all kinds of heuristics to turn it into reasonable data, and you always have to bear in mind that you're using data which may be faulty and stuff, and that is real life. And most real semantic web agents will be doing that unless they're in very limited closed worlds. Yeah, in fact, we're going to build a semantic web out of overlapping limited closed worlds.
I'm John McCarthy.
I would take my hat off.
One thing that I'm unhappy about in the development of the web is I'm a scientist, and the improvements for the benefit of mathematics seem not to have been made, so that when I read science or nature, the formulas are just awful, and they've been awful for many years and haven't improved. However, the second point, and there will only be this one, is more important. With regard to the logic, there are a lot of discoveries yet to be made. Nobody's going to go up and take the logic and say, oh, KIF is good enough, let's standardize on that. My opinion is that that won't work, that it can't be done till there are more discoveries. And the community that is making these discoveries is the knowledge representation community within the larger artificial intelligence community. Now, I understand you don't like AI.
Well, I'll deal with those one at a time. First of all, when you're publishing a math paper, yes, you can use MathML, but which you can embed in HTML, and some browsers will handle it. So in other words, there's a bunch of mathematicians who've gone to the trouble of making the language. What you have to do now is to somehow give the mathematics community a sufficient voice, a powerful voice, to get it implemented reliably in lots and lots of browsers. Or get them all to use one particular one, perhaps. So yeah, that has been a problem from the early days. And in fact, it's a bit silly because I'm told that if you look at newspapers, you'll find, so in almost any newspaper somewhere, there's a little bit of maths. So people actually do need to use mathematical symbols somewhere, just every now and again. So typesetters all have to be able to handle it. So why can't browsers all handle it? And there are lots of things where the technology is there, but it hasn't been deployed enough to be used. So that was like CSS style sheets were like that for a long time. We've got SVG is a very exciting technology, which has got, in fact, is quite well deployed for doing diagrams and stuff, actually, which is quite heartening. It's still not available to every single browser instantly. It should be just wrapped up and sent with everything. Scalable vector graphics are good, good way of doing it. They're much better than putting your diagrams in GIFs and stuff, because you can scale them up and down. And so MathML and SVG they are there, and it's a question of deployment. And I sort of sympathize with the problem. Now, as regards the logic, yes. There are, as I said, there are some fundamental problems out there in that there are different applications where people want to use particular logics. There's a group of people doing description logics. There's a group of people who want to go, do first order, and a lot of people who want to make it. Some people who want to make it simpler, simpler than DL, and so on. And you get clashes that I feel it's very important to have quotation in there, but most of these things don't mix with quotation at all. And yes, you're right, and the people who've been playing with this for years and years are the KR community. In fact, one of the things I've suggested is that people should go to existing things like KIF and webize them. In other words, do a version of KIF which has got, of your favorite flavor of KIF, which has got URIs in, which has got some namespaces at the top, and then uses URIs, and just see what happens when you take a lot of that stuff and use it in a web-like fashion. And then you'd be able to take RDF, for example, and OWL, and convert it into KIF, and it would carry through through the namespaces and be back convertible. So I suggested that should happen. So yes, that's all happened. Like a lot of really useful and very important things, important techniques and important languages, they've come out of the AI community, and that work is really important. What I have, and it is not true that I don't like AI. I also, I think that I'm very attracted to that. I think it's great fun, and I even have spent a certain amount of time with my son building robots, and fooling around with ELIZA type programs in my time. But the problem is that is one of representation of what's going to fit in where. So at the moment, when you look at the pyramid, it's got a very, very wide base, and that most of the stuff out there is just going to be data. When want to get all the financial data out there, and we want people to send their the bank statements and so on across in a way that can be converted into RDF, so it's got well-defined semantics. The logic we're talking about is extremely trivial. We're talking the logic it takes to actually add up and get the total of a bank statement. And are we supposed to leave? And I guess we've run over a little. So I thought it was the lights going out. And in fact, when people design ontologies, most of them are just defining classes in domain and range. Then now with OWL, some of them will probably define inverse properties and a few things like that. But they are not using description logic to its full power, and that some of them will probably a lot of rule-based systems out there, but most of the work which will get the biologists talking to the chemists does not involve a lot of complicated logic. It's a question of what is the term we are going to use for a hydrogen atom. I was down at Slack trying to suggest that people should define a good URI for each particle and get the particle database out there and just do it. Just convert it into IDF and stick it there so that when I talk about a new meson, I can give you a URI for it, and if you don't know what it is, you can go look it up and find out that it's a particle. And it's just very, very simple classification. And to use the stuff in the enterprise software, people are going to be using SQL. They're not going to be using, that's the level of their inference. They're going to be exporting this stuff and making systems which will be reliably ordering large quantities of soap powder when they want to, and sending out large numbers of bars of soap to the people who sell soap. And we want to make, so I want the basic, I want the bottom layers of the pyramid to be defined so that we are not getting into heuristics. We're not waiting for all these logical questions to be solved. So it's a question of messaging. The emphasis for deployment is on the non-AI-like stuff, the stuff which is just relational databases in a straggly, semi-structured fashion. Okay, because that's what drives industry, and that's what industry will commit to, and that's where you will get all the data. Now, when you've got all the data, it is going to be the most amazing playground for doing trying different sorts of inference, for trying, when you have, for example, huge number of rules exposed, even if they're boring SQL-like rules, if they're horn rules, if there may not be things you find exciting, then just having a very, very large number of them and finding what heuristics for these for situations where all the parameter knobs have been changed, we've got large numbers of rules and huge amounts of data, and we have to find a path through that. Even though we'll be able to probably index all the rules on the planet on the laptop fairly easily. So I think that the number of questions. So yeah, I think that all the work that's been done in this area will be. I think it's all waking up, and people are. There'll be a huge amount of investment necessary, and be a lot of research being done, and. But every time you call it AI, if you say yes, the semantic web is great AI, it's reasonable in that it's reasonable to take credit for the work that the AI community did in producing the languages and producing the techniques and producing things like Lisp, and the KI work and KIF and a lot of the KI work, and we've got the agent communication languages and stuff coming up. Yes, it is reasonable for the AI community to take credit, but it is unreasonable but what we don't want is for this label that it's going to we're going to make artificial human-like intelligence the strong AI label to get attached to what is incorrectly attached to what is really extremely boring from the AI point of view. It's just huge amounts of stuff in the initial phases. Does that make sense?
Research. What? So I'm not interested so much in the past as in the future. So I don't know. I'm not much interested in AI getting more credit for the things that it has done in the past. But I think there is more to be understood for the future. I'm a little worried about selling soap as being somehow the major importance for society. And finally, there is another question that worries me. If Slack makes this RDF for the hydrogen atom, then what if they want to change it next year?
What I would ask you to do if you publish something is give an expectation of whether you will change it. When somebody gets a namespace on our site, we reckon on the w3.org site to keep it forever and never reuse an identifier. But some identifiers are for documents which change. And what we want to do is to set expectations. So if you say, I'm going to make a new ontology and I want a namespace, and I'd like to have w3.org/2003/PDB. Can I have that, please? And I will say, or in fact, the machine will say to you, or the team, somebody will come back to you and say, well, what's your persistence policy? Can you choose a persistence policy? Will the terms never change? Will they change to the extent that you fix things which are clearly bugs and inconsistencies and typos? Or will they, and if they do change, if you do change, what will be your algorithm? Will you have back compatibility or forward compatibility and so on? And some people say, we will never change this at all. We will, if we change anything, any documentation about it by a bit, we will actually make a new version, give it a new name. And other people say, listen, these are our names. We are the community. We'll change them as much as we like until we get them right. And we will tell you, we may freeze them at some time, but we'll tell you. Now, if they want to take that through the process of the W3C standards process, they will have to freeze it at a certain point, and they'll never get allowed to change that. But typically, sort of the persistence policy matures. So that's the answer. I don't mind whether they change it or not, as long as they say up front, they make promises about whether they will, and if they promise not to change it, that then they stick to it.
Hi, my name is Michael Bierman, and you mentioned SVG earlier, and I wanted to ask you where you think it is relative to the adoption curve you talked about, and what's the best way to keep it moving forward, thinking in terms of the history of HTML and how, if you think they're analogous or if you think SVG is somehow different.
HTML was, I suppose, it's the warp and the weft. It's the way you get places on the web. And SVG in ways can be like that. You can make a whole web page out of SVG. Make sure it's accessible. But obviously, there's this sort of, HTML works. So why should we do anything else problem? I think that there are things, what will promote SVG? SVG is fairly far advanced. You can get plugins for pretty much anything. There's several implementations. There's some pretty solid implementations. There's some really nice things people have been doing, which is less interoperable, works with JavaScript running in an SVG, making a sort of live animated things, which then when you mouse over something, they go out onto the web and suck in RDF and pull more data in and then change the display. So there's some morphing SVG things which I think are really exciting. I think people will learn bit by bit, particularly as the same image is viewed on different systems. So, for example, there are all these. A lot of the things I had to zoom into were zoomed in because in those days we only had PNG and GIF. We only had GIFs. We only had pixel-oriented formats, the standards, and so I made it for the sort of 800 by 600 screen of the time. And now we got more pixels. So people will realize that there are now a huge number of varieties. That still you have you have phones and you have wristwatches with shrinking numbers of pixels, and you have screens with huge growing numbers of pictures. And people will actually see the same data, the same picture of what the weather is going to be tomorrow, on both screens. And using SVG, you can make it look beautiful on both. So I think people will get that and more. So yes, push. Talk to your, make sure that if you're involved in implementing a browser, that you or any sort of graphic user interface device, make sure it's SVG capable. Use it. Have a little button on there explaining to people how to download the necessary, maybe, but use it. It's fun. You can do a lot of things, and I think it may become a whole input-output medium as an interactive thing, because you can put links in it. You can make scripts which change the diagram as you mouse over it, and as you pick up more data, and so I think it's got a lot of potential.
This is the last question. That's it. Okay.
Oh, sorry.
Wait,
We're going to get thrown out.
It
is 9 o'clock.
My name is Jim Hunter, and I had a question on one of your diagrams that you showed.
Where are you?
Right here.
Back there.
Back there. Okay, right. I'm just.
One of your diagrams had a pink line for parts, and I noticed the pink line didn't go to the order block. It had a CRM in the center. Was there some reason for that?
No.
Okay.
Next question. If surely that would have 3.
I love that answer. The last question. I'm Chris Primesberger. I'm the news editor of the Open Source Development Network. I have one question for you. What would you like to invent next?
a sort of food container, so when you put it in the fridge, it automatically stores the date when you put some things in, so you don't have to remember to write on it.
Okay. I love it. Thanks a lot.